HTTP request and response splitting. So HTTP response splitting is a web application vulnerability that arises from improper user input validation and sanitization. Validation is the process, input validation is the process of checking whether user input meets certain criteria such as format, length, or range before accepting it. While input sanitization is the process of removing or escaping any potentially harmful or unwanted characters from user input or output, such as a CRLF sequence, and also HTML tags, scripts, or SQL commands. Um, about CRLF, um, CR and LF are special characters. Carriage return is used to reset to the beginning position of text of a line of text, while line feed or new line specifies the end of a line of text and the beginning of a new one. In HTML, these characters are represented by \r and \n respectively. Using using these characters in user input opens up vulnerabilities or exploits, which is why validation and sanitization are necessary. One form of exploit is these characters being used in the header. Using CRLF in the header of an HTTP request can allow the attacker to escape the header into the body of the site. And this is the entry point that allows for other attacks to be performed. So here's an example of how HTTP request and response headers, or how an HTTP request header looks like. Um, this is a sample request sent to google.com, and adding CRLF to the header could allow the attacker to escape the header and manipulate the body. So HTTP response splitting is an attack that creates an entry point for other attacks, as previously mentioned, and these other attacks include cross-site scripting or XSS, authentication bypass, cache poisoning, content spoofing, resource location spoofing, and session hijacking. So about how it works, attackers begin by identifying web vulnerabilities to gather information on its configuration and behavior. They do this in two ways. One, by sending test requests to observe how the server responds, which can be which can be done in three example ways. So one is through manual testing, where they manually explore different parts of the application through its URL parameters, form inputs, HTTP headers, to identify fields that accept user input and see if these are possible CRLF injection points. The second is through automated scanning tools. These automatically crawl through the application, identifying input fields and attempting to inject various payloads to detect vulnerabilities. And the third is fuzzing, wherein attackers send a large number of input values to systematically test for vulnerable points. So the second step is um, performing CRLF injection. CRLF injection is subsequently performed following the identification of vulnerable points for user input. Doing this eventually influences the behavior of front-end clients or systems. So in a CRLF injection, it splits a request response into multiple parts, allowing for content and header control. The browser interprets the latter split as a new response and executes it, resulting in end attacks. So, consequences. The CIA triad is a foundational concept in info security that um, represents three core principles and objectives that security measures should aim to achieve. These are confidentiality, integrity, and availability. Confidentiality protects information from unauthorized access, interception, and disclosure. It ensures that information is accessible only to those who are authorized to access. While integrity is the accuracy and consistency of data and the completeness and reliability of systems. It ensures that data is trustworthy and has not been altered through unauthorized modification, deletion, or corruption. And the third, availability ensures that information and resources are accessible and usable when needed by authorized users and applications. To do so, this involves system, network, and service resiliency against disruptions, failures, and attacks. So, the violated security properties um, for executing unauthorized commands is confidentiality, integrity, and availability, while gaining privileges violates confidentiality, access control, and authorization, and modifying data violates integrity. And for the next part, we're going to show the demo of um, HTTP request response splitting.
So we're here at the lab of the post-Swigger lab for this demonstration. So first what we're going to do is intercept the reload request made to the blog website and then forward it to Burp Suite and then get the request metadata from the blog. So we turn off intercept, and as soon as the request is captured, we forward it to the repeater where we are allowed to modify the request. So first we want to reproduce the response. So we got HTTP 200, and then finally we first check that the HTTP protocol is set to HTTP 2. Then we manipulate the path of a request by intentionally targeting a non-existent endpoint, which is /x. This consistently generates a 404 response from the server. So doing this, we mimic what an attacker does by testing how the server handles multiple non-existent endpoints, which helps us differentiate captured responses versus responses generated from other users' interactions with the application. So the next thing that we're going to do is to inject the request header with CRLF sequences and other request headers to manipulate the requests and smuggle them to our lab instance. Like we discussed, CRLF sequences split a header, making it two separate requests for the browser to interpret separately. That's our lab instance. So we're gonna copy that. Okay. So after some time, we eventually capture a 302 response. And there we go, containing the admin's post login cookie. So we copy this. We first access the admin part of the web application. First, of course, we copy the cookie, and then we try to access the admin panel with the /admin endpoint, and then we intercept this using the same technique we used earlier. There we go. Then we forward. Then we got the request, the redirect request. And then we copy the cookie we stole just now to the necessary header. So status header for /admin and cookie header for the cookie that we got earlier. And then we use these information to impersonate the admin's user session and then successfully log into the admin panel. There we go. So a 200 response indicates a successful login attempt. So there we go, following the instructions of the lab. We want to delete Carlos, the user Carlos. So we have to forward this request again. Send it to repeater. Then generate a response. So after which, right now, we're again manipulating the request headers to successfully delete user Carlos. So that was the session cookie we had just now, which illegally authorizes these modifications to the request header. We send this request over, and 302 found. We're gonna go back to proxy and forward. There we go, successfully deleted.